Okay, we're back with example C. So to get started here, I'm going to factor the top and the bottom of my equation. And what I notice is that there is a factor that's going to cancel there. So I know that there's a whole at x equals 2. There's also a vertical asymptote because there's a remaining factor in the denominator. So I can see that there is a vertical asymptote at x equals -2. So I'm going to take a look at the behavior on either side of that vertical asymptote by taking the limit as I approach -2 from the left and taking the limit as I approach -2 from the right. Now I can just use that remaining function because I know that that x minus 2 factor canceled and became a whole. So I'm just going to consider the x plus 3 over the x plus 2 as I'm doing this. So for the numerator, I can just plug in the -2. And I can see there that I'm going to get -2 plus 3. And then in the denominator, when I plug in a number that's a little bit to the left of -2, I'm going to get almost 0, but a little bit smaller, a little bit negative. So on the top, I've got a +1, and +1 divided by almost 0, but negative would give me -infinity. And then on the other side here, I can plug in the -2 on the top again, and again, I'm going to get +1. And then on the bottom, when I plug in -2, but a little bit bigger, so like -1.999, and add 2, I'm going to end up with almost 0, but a bit positive. So now I've got a positive divided by a positive, and dividing by almost 0 gives me an infinity. So I can see here, if I was thinking about doing a rough sketch to build my question, so I would be doing that on the whiteboard right now, I'd be approaching -infinity on the left of my asymptote and positive infinity on the right of my asymptote. Next, we're going to take a look at the horizontal asymptote. Now, if I'm remembering my trick from MHF4U, I'm looking at that lead coefficient because I have matching degrees, a degree of 1 on top and a degree of 1 on the bottom. Or you could look at the original matching degrees as well, same coefficients. So I just need to divide those two coefficients, and I know that my horizontal asymptote should be at y equals 1. We're going to prove it using limits. So we're going to take a look at what's going on the left side of the graph. So as I approach -infinity, what's happening to my function. And remember, I don't need to include the whole anymore. And then we'll take a look at what's happening on the right side of the graph over here. Now, when I'm taking the limit as I approach infinity, we'll use our trick of factoring out the x sorry. The x's are going to cancel, and then I can take the limit. So taking the limit as x goes to -infinity, I'm going to get 1 plus almost 0. And then taking the limit as x goes to infinity on the bottom, I get 1 plus almost 0 again, and 1 divided by 1 is 1. For the other limit here, again, we could factor out that x and it would cancel out, so I would be left with this here. And when I plug in an infinity, for those x's, those denominators are going to help that term get closer and closer to 0. So again, I'll end up with 1 plus 0 over 1 plus 0, which is approaching 1. So there's my proof that there is a horizontal asymptote on the outsides of the graph when I'm heading towards those infinities at y equals 1. So that was my asymptote step of my curve sketching algorithm. Next, I'm going to take a look at my, my intercepts. So first I can find my y-intercept, and when I plug 0 into x plus 3 over x plus 2, I end up with 3/2. And then for my x-intercept, I'm trying to figure out where does the numerator equal 0, and I can see that that's at -3. So next, taking a look at my max-mins, and my intervals of increase and decrease, I know that I'm going to take my derivative, and then we'll find our critical points. So taking the derivative, I take the derivative of the top. Now remember, I am using my reduced version, so I'm not using the original question. I'm using it after I canceled the wholes. So the derivative of the top is just 1 times the bottom, and then I subtract the top times the derivative of the bottom all over the bottom square. And then when I simplify this on the top, I'm going to end up with x minus x, which goes away, and then I'm going to end up with 2 minus 3, which is just -1. And then on the bottom, we're going to leave that factored. So now I'm looking for the critical point. So I'm looking for where does this derivative equal 0? And that, of course, has no solutions. So there are no flat points on this graph. And then f prime at x does not exist when x is equal to -2. Now remember, this was our vertical asymptote, so there are no critical points on this graph. But I'm going to find those intervals of increase and decrease by looking at my chart. And so my chart is only going to consist of my vertical asymptote. So you can remind yourself of that. We're going to find a test point. We're going to find the sine of f prime. And again, we're looking at that simplified version. So the -1 over x plus 2 squared. And then finally, we can talk about if f at x is increasing or decreasing. So picking a test point, anything smaller than -2, anything bigger than -2, we'll plug it into that derivative. The top of the derivative is always negative because it's -1. And then plugging in -3 on the bottom, I'm actually going to square whatever's on the bottom. So I actually don't care what I'm plugging in. The top is always going to be negative and the bottom's always going to be positive because we're squaring. So on both sides here, I end up with a decreasing function. So we've got our intervals of decrease. Oh, one more thing that we need are some nice points. One of the nice points that you need to include is that hole. So our hole was at x equals 2, so make sure that you figure out where to place that hole. So we'll plug 2 into our simplified function x plus 3 over x plus 2, and that gives me 5/4. And then we'll find a couple more points. Right now, I don't have a lot of points on the right-hand side of my vertical asymptote, so I'm going to plug in -1, and I see that I'd be up at 2. And then I'll do one more point on the left side of the vertical asymptote as well, and at -4 I'd be up at 1/2. So we're going to draw a picture of this graph. So I've placed my axes thinking about where some of my points are, and my rough sketch would help me place those axes as well. Don't forget, I usually do that off to the side as I'm working through each of the pieces. So I can start to add a scale to my graph. I know I need to see over to -4 and over to +2. And then going up, I need to see up to +2. So I can actually count with quite a big scale here. And then I can start to add some stuff to my graph. So I can add my asymptotes. I've got my horizontal asymptote at 1 and my vertical asymptote at -2. And then I can start to add some of my points. So I had a y-intercept at 3/2, or 1.5, and an x-intercept at -3. And then I had a hole when I go over to 2 and I go up to 5/4 or 1.25. So I know that there's an open circle here. Make sure that I can see that open circle. I'm just going to drag it. It's not aligned. Oops. So make sure I can see that it is an open circle. And then I can connect the dots on the right-hand side there. I'm going to get closer to my vertical asymptote and my horizontal asymptote. On the left-hand side, I've got one more point to plot at -4 and up to 1/2. And then again, I can connect. I've got my graph. All right, and I'll be right back with example D.